And then we continue with a presentation made by my colleague Martijntje Vollebrecht about Food Circle 4. Because what you saw this morning and what Kosja told and Leonor told, nice opportunities of processing of fruit and vegetables. But what you also have seen this morning, that there are some side streams coming out of it. And that was also the case with Kosja and also Leonor, you also had side streams. So in Food Circle 4, we look at upcycling of those side streams. Hopefully it works. Yeah. And also here we start with this nice infographic. So we will have all kinds of different side streams. And the first question is what to do with it. And that I will tell you a little bit more about that. We developed a tool for that, the Procestimator, to select what are the characteristics of the side streams, what are the opportunities, what technologies, but also what cost and what impact involved. Important part is the mild processing of the side streams. And that then give multiple opportunities for business applications. Because there are some challenges with side streams of fruits and vegetables. They are very nice, they are food grade when they occur, but they also, the shelf life is very short. And there are large variations in volume. And also during the season, at a certain moment, we maybe have a supply of a lot of berries, as in for the zero waste project. And a month later, we don't have it. So you need really to look at what can we do with it. And if you really want to have specific components out of it, then let's focus on the functionality. In this Food Circle, we work together with 4 partners, Van Rijsingen Ingredients, delivering side streams, especially with the focus on the project on peas, green peas and carrot side streams. Foodtech Brainport, technology supplier. Hutte, a caterer, and Tobias Kamps is in the panel discussion later on in this afternoon. And Wageningen, where we did a lot of the research part in this Food Circle. So we start with ingredients with good functionality. And we want to keep that. So we want to apply mild processes to preserve the national ingredients, the color, the texture, the other functionalities. But you also have to think about inactivation of microorganisms and for some products also enzymes that causes browning of, for example, apples. And those side streams contain a lot of water. Sometimes nice, but if you want to do something with it, then sometimes also removing water is important. So we have side streams. We want to stabilize the side streams, and then we would like to make ingredients out of it. And so, and we want to evaluate what are we going to do with it. Biogas is of course also an option, but we wanted to apply more higher level feed or preferably to ingredients for food products. But what to do? And is it indeed feasible cost-wise or equipment-wise? And is it also more sustainable? And that is why we developed a Procestimator, an expert tool where companies can work together with us to evaluate if a specific side stream, what can you do with it? So we start with the characterization of the side stream, what kind of processing equipment is in it, what to do with it, process conditions, and you see quite some details here. There are much more details in the system, but it is really a technological tool giving advice to the companies what to do with those side streams. And what we are aiming to total use the side streams. So not only removing that very nice, tiny functional ingredient, what to do with the rest. It is always important to look at the entire side streams. What I said, it is an expert tool, so you need food processing knowledge, and we would couple different processes after each other. So it is not a single process, but it is first, for example, stabilizing the side stream, then an extraction method, then doing something of the rest. And we use a lot of data that is already available in databases. So not starting from scratch. And then as an output, there come multiple scenarios. So that is also in a discussion with the companies, we can give advice. You can do it like this, maybe very relatively cheap, but also what you get from it is maybe not the highest outcome. So what if? Really those scenario analysis is important. And my colleague Bert Dijking, he's in the audience. I don't see him. There. He is really the expert on the process estimator. So if you have any questions, please go to Bert in the coffee break. But one important thing is the upcycling of green peas. And I can tell something about it, but I also have a video, and I hope it now works that the video starts. No. It shows that green peas, they are growing on the field for frozen peas, to have a supply of frozen peas. It is contract farming with farmers of Van Rijsingen. And usually there are more peas sown than necessary. So if you have a good year, you have a lot of surplus peas. What are you going to do with that? That is what we use the process estimator for, to discuss what is possible. And what we did is that we keep the green peas on the field, let them mature to dry peas, and then harvest the dry peas, and then apply separation processes on it to make really high protein fractions of it. And those protein fractions are used by Hutton in the catering also to supply high protein ingredients to specific groups of customers of them. So that gives an example that, what you do with these green peas, normally they are just feed or just thrown away. But now with this, we can make very nice dishes out of it. And in one of the previous Fox meetings, we tasted this naan bread made of that pea flour with a pea spread, and also this sponge cake was made out of the material that otherwise was wasted. And you see here an example to the right of the process, what was done in the process estimator to evaluate what is possible and what not. What we learned from the side streams, that if you upcycle plant-based side streams, that then can really improve the sustainability of the entire system. So not only the main product, but also the side streams are important. But you have to think what to do with it. What processing is possible, what not. And what you really have to think to compare the sustainability impact of that processing step with what is done now. Sometimes also the current options are very sustainable already. And so this really case specifics. Important topic are the costs. You can think about very nice components and maybe think, oh, the kilogram price is okay. But if the entire cost is too high, then it is not possible to do it. And what we really showed is that mild processing helps because they lower the footprint, and more important, they also maintain the quality, the fresh quality of the product and some functional components. Some practical recommendations. So really think about your side streams, not only the main thing, but also using the side streams. And the process estimator can help selecting pathways to process these side streams. And let's have a look. Yeah, and I think that is the main message also from this part. Look at what is a good application of your side stream, and especially for fruit and vegetables, taking into account the seasonal varieties, the shelf life of the product, and to keep it as food as long as possible. So thank you very much for this presentation. And before I go to the questions, the video is ready. So now no questions allowed. Yeah, do I have to press? Or
technologies help with the valorization of side streams into high valuable food ingredients and food products. Within the FOX project, Food Processing in a Box, organizations, companies, and research institutes work together, create business opportunities upcycling food side streams into high-quality products by applying innovative mild processing technologies. In this video, we will show how surplus peas can be valorized into pea protein power. It all starts with the cultivation of pea plants. We had one of pea fields of Van Wageningen. The crops are planted in February. To ensure that the demand for peas can be fulfilled, extra crops are planted, but weather conditions can, for example, decrease the yield. So most years there is a surplus of pea, but in different volumes. Now we collect the surplus peas. After some trials at Wageningen University, we decided to toast the peas in the oven to remove the beany flavor. The beans are grinded into coarse flour. The coarse flour is transported to the mill. The right settings are needed. The coarse flour is now milled into fine flour. The flour is collected. The protein content is too low to create high protein foods. We need to remove the starch content to obtain protein-rich flour. 78 kg flour is ready for the next step. We have to lift it in order to place the flour in tank, so we can dissolve it and set the right pH. The pea flour is placed into the decanter for separation of the protein from the starch. A sample is taken to make sure the process is going well. After the decantation step, still some protein remains in the liquid. Therefore, we centrifuge the liquid to recover all pea protein so nothing goes to waste. Now we have separated the starch from the protein. The starch we will use later on. Now we focus on the pea protein. The protein-rich liquid is prepared for the drying process. What is added in this process to obtain a less viscous product that is pumpable through pipes? This is essential for further processing. The protein-rich product is pasteurized to preserve it for a longer time. Therefore, it is heated till 75 degrees Celsius. Now it is time to drain the protein-rich liquid into powder. To see which drying technology is the most suitable, two processes are carried out. The first one is spray drying. The liquid is sprayed into small droplets that are heated, so the water will evaporate quickly. The second one is agitated thin film drying, an innovative technology that enables drying low temperature. This is one of the mild technologies on which the FOX project focuses on. The starch-rich paste is placed in the agitated thin film dryer. The right parameters are selected. Within a few minutes, the first batch of dried powder is produced. From pot to pea to flour. The protein-rich flour can be used by Hutton. This flour almost consists of 70% protein. After experimenting, our chef from Hutton came up with a nice protein-rich dish. Let's start to make a pea spread with extra pea flour to higher the protein levels. The pea spread will be served on a naan bread. This bread is made with the pea flour. After mixing, kneading, rising, and baking, the bread is ready. Looks pretty fluffy, right? We have the pea spread and the pea naan. Time to finish the dish. We add some green asparagus, lettuce, and herbs. The chef also made this delicious sponge cake from pea flour. Within the Volks food processing in Box, we developed a process to valorize the surplus piece into high-protein flour by using a mild separation process. We demonstrated that the flour can be used as ingredients in savory and sweet dishes. In this project, Van Rijsingen Green, Hutten, Wageningen Food and Bio-based Research and FoodTech Brainport work together. The project is funded under the EU Horizon 2020 program.
Thank you. Yeah, thank you very much. And I'm looking at my watch. A short question, if there is any. Yeah? Yeah, let's wait for the microphone because that really helps.
So usually when we talk about upscaling by products or as you said, usually the yield of production is kind of low. So like the extraction of functional ingredients to valorize it. Is it, as this small of production in the box, profitable, the yield of production is good to be able to produce a certain amount of product at the end?
Yeah, but what we showed also in the process estimator that it is really case by case different.
Yes.
And what you saw in the video, an example that we didn't focus on minor components, but really on the protein itself. And that, of course, also helps.
Okay,
Yeah.
Thank you.
Okay, thank you. Then please come to me, to Bert, in the coffee break, because we have to follow the time schedule.